Assalamu alaikum. Today topic is the form of amplitude modulation. We know that amplitude modulation consists of the carrier wave plus the two sideband. As we have studied before in the last lecture, that this is the carrier wave, and here we have the upper sideband and the lower sideband. So its main modulated signal consists of these three necessary components. One is the carrier wave, other is the upper sideband and the lower sideband. So this is modulated signal. So it is not necessary to transmit all the modulated signal from one place to another place with the help of antenna. We can eliminate one of the portion. We can remove upper sideband, we can remove this, we can remove this, because all these components have their own power component. This has the maximum power of the transmitted wave, so these have the lowest power, so we can eliminate to any one of the component. So it is not necessary to transmit all three components which enable the receiver to reconstruct the audio signal or the original signal, reconstruct the original signal. So the importance of this form of modulation is that we want to save the time, we want to save the power, we want to save the money as well. So these are the factors, and the advantage we may remove for this, we may remove the carrier wave, or we can remove the one of the sidebands. So we can remove this carrier wave as well as we can remove this sideband, or we can remove the carrier wave with the sideband. There are three possibilities. So the different suppressed component systems are discussed here. Number one, that is DSBSC. That is stand for double sideband with the suppressed carrier wave. Double sideband with suppressed carrier. So from this figure we can see that this is the suppressed carrier, mean FC is suppressed or it is removed from the signal. Only the double sideband, that is the upper sideband, and here the lower sideband is present. So this is the form of DSBSC, double sideband suppressed carrier wave. So here the carrier component is suppressed. Carrier component is suppressed. The next, which will save a numerous amount of power. amount of power. The carrier signal carrier wave or carrier signal contains 66.7% of total transmitting power. Of total transmitting power. 66.7%. By the removal of this component, we will save 66.7% power. So, for m is equal to 1, when the percentage modulation is 1, the power saving will be 66.7% at 100% modulation. Now the next option of the suppressed component is B, that is SSB TC. Single sideband transmit carrier wave. Mean single side band suppressed but other sideband and carrier transmitted. The figure is represented like this. This is the carrier wave and this will be the band which will be transmitted, and only the single band upper, this is the lower side band, and the upper side band is suppressed. So upper side band, when the upper side band is suppressed for m is equal to 1, so the power saved will be is 1/6 of total transmitted power. So from this option we can see that the less power is saved by eliminating a single sideband. The next option, the third one, is SSB, single sideband, and SC. The third option, C, that is SSB SC. Single sideband, it is the most dramatic suppression of all the previous one, in which one sideband and carrier is suppressed. Only one sideband is transmitted. Only one side, and from the figure we can see that this is the carrier wave and this is the upper sideband and this is the lower sideband. So only lower sideband is transmitted from one place to another place with the help of antenna. The upper sideband and this frequency, the carrier wave frequency, both are suppressed. So the power consumed by this is, we know that this is 66.7% and the power consumed by this is 16.6%. So by compressing this component and this component, we will save the total power is 83.3% of transmitted of modulated wave. So you can see by suppression we can save a lot of power. So from this, the carrier wave, why we have suppressed these components, and is there any no effect to elimination of these components on the transmission of the signal waves or the quality on the transmitted wave? No, the quality will be remain the same and the transmission will remain the same. So just we are going to efficient our signal. So why these are not affected? Because carrier wave convey no information. It is just the carrier wave. Okay, and the two side bands are the mirror of each other. Are the mirror of each other. So by eliminating one side band, the other side band have all the information about that signal. So there is no loss of your information. So we can discard the one side band and one carrier wave. So the advantage of this elimination of two factors are, what will be the advantage? Number one, total power saving. That is 83.3% of the total transmission. Number two is the bandwidth. So now what will be the bandwidth? Bandwidth is very narrow because it is just consist of this band. Bandwidth is reduced by half. That is 50% of the modulated wave. And number three, the size of power supply is very small. The size of the power supply which required to in the circuit is very small, of the very small capacity. Number four, SSB has narrow bandwidth. So these are all the advantages of eliminating the amplitude modulation, eliminating different factors in the amplitude modulation. So read it carefully, and the notes is also updated in the group. So is there any question? Then let me know. Thank you very much.